Hello. In this video we will start talking about energy of a system. Let's consider this. If I take a block and I push and there is friction, well, and then I know that if I'm pushing with this force, the friction is going to oppose, and then after a while this thing will move with a certain acceleration. But if you touch the block, you will notice that it got warm. Why? Our accelerations, our velocities, our positions, forces and friction forces alone cannot explain why the block gets warm, why the table gets warm when friction acts, right? So in this chapter and in these videos, we're going to start talking about this concept, this phenomenon, which clearly needs more than just the concepts of acceleration or mechanics we have, kinematics and dynamics we have studied so far. A new quantity will be required to understand why the block gets warm, and that quantity is energy. And I'm not going to define energy right now. Before that, I am going to focus on the other word I wrote here, which is system. So before, when we were dealing with dynamics, we will model an object, let's say a block, as a body or as a particle, right? And then we would analyze the forces acting on this thing, a normal, friction, whatever, tensions, and all that. Well, now instead of using the particle model, we are going to use the system model. Let me tell you what this is. A system is just a portion of the universe that we want to study, that is of interest to us. Let's put it like this. The system could be an object, just like before, could be a particle, could be a collection of particles. Let's put it like this. Could be a region of space. Could change in time. Could change in time. Could change the size, right? It has boundaries. Those are cool. These boundaries could be real or imaginary, right? Real or imaginary. Let's consider a few examples. Imagine you have an apple and you have the earth, right? So your system depends what you want to analyze. If you want to analyze, for instance, the apple, and whatever you see, this is actually, let me do this again. I'm going to draw an imaginary boundary. So, of course, boundary. Here we have the system, and everything outside is the environment. If you put together system, boundary, and environment, you have the universe. I'm missing an I here, environment. In this case, we can, for example, talk about the interactions between the environment and the system. And one of them is the force that crosses the boundary and that is exerted by the earth on the apple. You see, the force crosses the boundary, but it comes from an external agent, right? It comes from the outside of the system. If I were to repeat this, let's the apple again and the earth, and I define my system as containing both the apple and the earth, then whatever forces are here, it's a force of attraction. Here, of course, there is another one, the force with which the apple pulls on the earth. But here, if I do it like that, the earth and the apple are inside my system, so these forces are internal. Okay, so we'll get there, but first step in doing problems involving energy is to define the system by means of a boundary. Okay, let me give you another example. Let's consider this example from an earlier chapter. I can define the system in whatever way I may want. For instance, I can define the boundary to be like this. That's a possibility, right? That includes the rope. Okay, so I'm very bad at drawing. Okay, if I define then this inside, everything inside the purple, this is my system. Okay, and then, well, then everything that is not my system is the environment, and we can here observe in which way the environment interacts with the system. For instance, interacts through friction. Friction is provided by the block on it. All the weights are a means for the environment to interact with the system. Even the force that here the pulley exerts on the rope. Okay, what is not external to the system? Well, the tension, which is the interaction between the rope and the masses. That's internal, right? And so it's very important to identify the system, the boundary, the environment, what is external and what is internal to the system, all the internal interactions. Because one way, I'm going to write it even, one way in which the environment can interact with a system is through a quantity we will define eventually as work. And this will be explained in the next video.